when we get to a story problem, when we start highlighting things, we're usually drawn to the numbers, right? So Clara is investing the $5,000 in an account that pays 6.25% interest per year. After how many years will her investment be worth $10,000? Now, you know, I also like to highlight what the question is. What are we trying to find? After how many years will her investment be worth that much? Okay, so here's our plan. We want to identify if this is growth or decay. So she's investing and is getting paid interest. So is her money going to grow or is it going to decay? It's going to do what? If you're getting paid interest, it's going to do what? It's going to grow. Okay, so this is exponential growth. So exponential growth, we're going to use our model, which is y equals a times 1 plus r to the power of t. So the next thing I like to do is identify these values in my story problem. So I know a is the initial value. She starts with 5,000. That's going to be your a value. The 6.25%, that is your rate, and we talked about when you have rate, you're going to express that as a decimal. So we're going to move 2 decimal points back, which is going to make this 0.0625. And then after how many years, you're trying to find the years, which means you're going to try to find t. And then you want to know when it will be worth 2,000. That is going to be your y value. That's when the final amount would be 10,000. So we're going to plug those values into the model, which means I would have 10,000 equals 5,000. 1 plus your r is going to be 1.0625 if you were to add those together. Okay, and then usually we would try to solve this using algebra. Okay, but do we know how to solve an exponential function yet? No, we do not. That is something that we are going to learn this chapter, but we just don't know how to do that. Okay, so what we do know how to do is use the graph to solve. And if we're going to be using our graph, I am going to let you use your table. We want to know what we're going to plug into y equals. And our model is y equals 5,000, 1.0625 to the power of t. Okay, this is what we call our growth model. This is what we are going to graph and find the table for. And then we are going to estimate our value using that graph. Okay? So we're going to put that into our graphing calculator. So we have 5,000, 1.0625, and then we are just going to use to the x. That is perfectly fine. Now, because we are dealing with a story problem, when we go to our table, I'm also going to make my table start at 0, and I'm going to switch this back so I'm going by 1 so I can look and see what's happening here. Because it is a story problem, we only have to worry about the values of x that are positive, or time is positive. So at 0, I'm at 5,000, which I know because that's my initial value. And then remember that we are trying to find out when it's 10,000, so I'm going to go over that. In fact, in this one, I am going to go by 5s again. So 0, 5, 10, 15, 20. So we're at least going to go out to 20. So if you want to do your table set, and this means change in the table, if you want to go by 5s, so you don't have to scroll, you can absolutely do that. And it's okay if you do the whole numbers here. Now, once I get to the 12,000, I know I definitely have enough information for this. But now to plot on my graph. Okay, so I'm using my table there, and I have enough spaces here where I can actually go by 2.5, so every other one I'm going to go 5, 10, 15, 20. I even have enough space to go out to 25, so I'm just going to keep that in mind. I have 16,000 here, so I'll want to go up to 20,000. So I'm going to make my scale for the y's by 2,000. So this will be 2,000, 4,000, 6,000, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, and then I'm just going to plot my points. So I have 0, 5,000. So this is 2, 4. So this would be my 5,000. At 5, I'm at 67. So that's going to be about halfway. At 10, I'm almost to 10,000. 15, I'm at a little bit over 12,000. At 20, I'm almost to 17,000, so I'm going to put that about halfway. And then, like I said, to make my graph, to span that graph at 25, I'm at 22,000, so that's actually going to be a little bit, this is 22,000, it'll be a little bit off there, but now I have like a point that I know I want to go to. And when you connect this, you are connecting it with a curve. There's a little bump in there. And then what you can do to estimate using the graph is you want to draw in that line of y equals 10,000. And I'm going to do that with my highlighter. Okay, now if you are just using the graph, when you estimate with the graph, your handmade graph, what you would do is you would find that intersection point, okay, and then I would take a straight edge to go down, and you can see if I'm going by 2.5, this is 10, this would be 12 and a half. I might estimate that to about 12 years. Okay, with the handmade graph. Now, we could also estimate this on our graphing calculator. Because remember, the way I came up with 12 is I really am going by 2.5 each one of those. Okay, but we know that when we do things by hand, sometimes there can be an error because I am estimating a lot of those points, right? Because it's a really big scale. So another way that you could do this would be, see how you already have this in your graphing calculator? This line here, okay? I could do another line where I just make it 10,000, and I'm going to show you how to use the intersect feature. Now when you do your window, you can't just do a little 10 by 10, right? So my minimum that I used was 0, and then I went up to 25, so do the same, and then we scaled it by 5s. For the Y minimum, it was 0. What was our Y maximum? 20,000. And what was our scale? 2,000. So you can just make your scale the exact same. And now when you graph, it's going to graph the function first, and then it's going to graph that line of 10,000. Your intersect feature is second, calc, and then this is number 5, intersect. And it's going to ask you, where are you on the first curve? So you're just going to try to get as close to the intersection as possible. Same thing on the second curve, you're just going to try to get close to that intersection as possible. And then you're going to guess. And look, it'll tell you the intersection. So what is your x value when y is 10,000? About 11.4. So really, our handmade graph was not too far off. So intercept on GC is going to give you the time is 11.4 years. Okay? So I do want you to use that feature, and then we'll write down the second. Look at this great bell-to-bell teaching, Mrs. Butcher. Somebody told me last week, they're like, we were working bell-to-bell. I'm like, when you see Mrs. Butcher in the hallway, you go tell her that.
That's good.
Okay, so you're going to do second and then go to calc, and then it's the intersect. So it's very, very close to that maximum and minimum, and this is going to give you a more exact value. And again, that is because when we're plotting this by hand, right, I'm estimating the 67, 70. It's going to be nearly impossible for me to do that by hand when I'm going by 2000s. Do you guys understand that part of it? Okay, so that's why we do want to use this, and when you're checking your answers in the back, you are going to want to be as close as possible. Okay? All right, so we're going to do example 3 as our warm up tomorrow, and then your homework is page 237, and it's numbers 1 through 11. Okay, and you'll still be able to do that. This is section 4.1. Okay, and the best thing that you can do to prepare for your assessments is doing that homework. Okay, and then by the end of 5th hour today, there will be a spot for you to submit.